Today we're covering DTLS connection ID and how it enables low-power IoT devices to maintain their secure connection with the network even after going to sleep for a long time. Keep watching if you're building a low-powered IoT device or if your device moves between networks a lot. Welcome back to Goliath. Today we're going to be talking about connection ID in DTLS, and I brought Dan with me here. Welcome, Dan.
Hey, Chris. Thanks for having me.
Yeah. So Dan is our cloud lead. He knows so many more things. I see Wireshark on Dan's screen all the time. We are going to see a little bit more of that here today. So maybe we start with, there's a lot of layers here, right? Where do we start in the stack of all these things? Or where do we start?
Let's start at the top and kind of go down from there, I feel like, especially because we've had some content, I think, on the Goliath blog and that sort of thing that touches on that. So maybe we start up at CoApp. Does that sound good?
Maybe we start even sooner than that. If you are a hardware person like me, you don't have to worry about any of this stuff.
Right.
I'm not saying don't watch. It's actually this stuff is super, super interesting. It's like all the stuff that's under the surface that actually makes your IoT thing work. But, if you're using the Goliath SDK, the Zephyr SDK, the ESP IDF, or the firmware SDK, all of these things make you not have to worry about it. A lot of it is handled for you there. You can, of course, dig into it. You can troubleshoot. You're going to see all the things that Dan's talking about here, but you don't have to worry about it. But once you do, it's like super cool to see this stuff we're going to talk about, right?
Yeah, absolutely. And it's been a lot of fun to work on this. And I think, like you said, despite hopefully users of Goliath never having to kind of think about this kind of layer of the stack, giving insight into it and also just talking about how we do things, from an engineering culture perspective here at Goliath, I think is something that, we're kind of passionate about within the engineering team at Goliath. So I'm super excited to share that today.
Yes. Awesome. Okay. So CoApp, what is CoApp?
Yeah. So CoApp, it stands for the Constrained Application Protocol. And so basically it is akin to how HTTP is to TCP. You might say CoApp is to UDP. And the goal there is when you remove the connection oriented protocol of TCP and you instead put in a connectionless protocol of UDP, it allows you to have more flexibility about the reliability of the messages that you're sending.
Great. And I will point out, like Dan said, great blog post from Dan in continuing series. You'll see more and more stuff about this from Dan. That's probably the best place to go and get like detailed information about it. Now, how does DTLS fit in that?
Absolutely. So DTLS kind of sits in between CoApp and UDP. I know a lot of folks who are watching this video and a lot of folks just in the world are really familiar with TLS. It's the thing that adds the little lock at the top of your browser bar up there. And so
somewhere up here if you're on YouTube.
Right, exactly. If you're watching on your phone, can't help you.
Yeah, sorry.
But so TLS operates over TCP, and it basically establishes a secure channel over that connection-oriented protocol. DTLS is kind of the sibling protocol there, and it establishes a secure channel over UDP. Now, we already mentioned that UDP is a connectionless protocol, so some of that state we have to maintain up in the DTLS level. So it adds a little bit more complexity, but the bottom line is we're just trying to ensure that all of the data you send from your device to the cloud is over a secure channel.
Right. Yes. Okay. So now we're down. We're moving on down, right? So now connection ID is a new part of DTLS, like new, right? Pretty new. Or
it's fairly new. So we're talking about DTLS 1.2 today. There actually is a DTLS 1.3 now. It's not widely deployed at this point. And DTLS 1.3 actually has the functionality that we're talking about today built into it. So basically, DTLS 1.2 was introduced. They realized it kind of had this shortcoming for this certain area, and then they added it as kind of built into the 1.3 specification. So yeah, we're talking about DTLS 1.2 today, which has been around for a few years.
Okay. All right. So now let's talk about the problem space. I have a cellular device. It is on my bench. It talks to the tower. I want to save battery. I put it to sleep. And then, I don't know, 2 minutes, 5 minutes, 10 minutes, it gets reassigned an IP address, right?
Yeah, absolutely. So cellular networks this is really common, and IP addresses and ports are reassigned fairly regularly. Could be any device, right? But this is the type that it impacts most significantly. There's also the aspect of, you're talking about the cellular device. If it's in motion, or if it's just sleeping, it may not have access to, continual power. And so you're also trying to look for ways all the time to save power so that it can last longer on whatever power source, battery, most of the time that it's utilizing there.
Yeah. Okay. And then, so then part of that problem then is now it goes to sleep, wakes back up, has a new IP address, has a new port, and it looks different to which layer? To DTLS? It basically has to start over, right? I mean, it has to be a new
exactly. Device. So at the beginning of the DTLS secure channel establishment there, you have to perform a handshake, which basically consists of sending some information back and forth that allows you to, set up a cryptographically secure channel there. UDP being connectionless doesn't have any way to say, hey, these packets are coming from this device that has been identified before in the past. It's just saying, hey, I got a new datagram. It came from this IP address and port. Here you go, DTLS. Do with it what you will. So if you have a new IP address and port, by default, DTLS 1.2 is going to use the IP address and port as the identifier for the connection. And so that's basically what it's going to use to say, hey, should I use this connection state that I'm holding to try to decrypt this packet? So the issue is, if you get a new packet that comes in that has an IP address and port that maybe you haven't seen before, then how do you know which connection state to associate that with?
Okay. And then, so now,
right. I left you on the cliffhanger right? there. Yeah. So, right. What connection IDs do is they basically allow you to negotiate an alternative identifier that can persist across changes in IP address and port, which means that if you go to sleep for a few minutes, you get assigned a new IP address and port when you wake up. Maybe you're just sending, like one packet. Maybe it's, keep alive or just a sensor reading or something like that. You don't want to have to perform that whole handshake again, which has some cryptographically expensive operations that you have to perform. Instead, you just want to send that packet and have that delivered to the server. And so you attach that connection ID to it, and then it's able to be associated with the right connection on the server and be handled correctly.
Right. And that's a really good point, that cryptographically expensive thing. It's battery, right? Because you have to crunch on the numbers, but then you also have to send data. And then maybe you're like, oh, it's not that big a deal if I do that every, once in a while. But you think every time you wake up, if you're expecting to only be sending, 500 bytes of data, 1K of data, and then you have to add layer stuff on top of it, or even less. I'm not even sure. What are the scales that we're talking about here? I don't have a good feel for that.
Yeah, so it depends a little bit on the type of handshake you're performing, in terms of how much data you're going to be sending per handshake. Really, and that does affect things like your costs if you're paying for cellular bandwidth there. But really, the computation aspect of it is what's going to be pretty expensive. So you're really trying to minimize that and do it as infrequently as possible. And like we talked about there, if you're going to sleep for just about the same amount of time that it takes to reassign an IP address, then you're going to be doing this pretty much every time you're sending data.
Right. Yeah, and that really starts to layer on top. Yeah. Okay. All right. Cool. Well, so then now connection ID, you kind of have this way to say that, hey, I've already been through this gate before. I've already punched my ticket. I was telling Dan the silly anecdote before. I was like, what if it's like when you leave the park to go to your car to get something, like they stamp your hand to know that you've already paid your ticket? Is it kind of like that, or are there better analogies here?
It's kind of like that if every stamp they gave to each person was unique.
Yeah. Okay. Okay. Yeah. Right. They moved little numbers on it. Okay.
Right.
All right. So you're going to show us this in action. Is there anything we should know before we see this kind of working?
No, I don't think so. For this demo specifically, I'm going to be using pre-shared keys. So that is a way of performing a handshake that doesn't use certificates. Instead, basically the client and server need to agree upon a credential beforehand through some other channel, right? And in this case, I'm going to be using a simple PSK. So basically, the server has, the client has, and they have an ID for that PSK, and the client's going to say, hey, I'm going to use this PSK identified by this ID. And the server is going to say, I've got that PSK, and they're able to establish a secure channel using that. That does actually involve less steps in the DTLS handshake when you use that as the cipher suite that you're going with. but it also makes it a little easier to dive into in a demo here. So just prefacing with that.
Okay, actually, that's a good point. As you pull up your screen too, I was thinking one other thing that I've heard people say in the past, which is kind of insane to me, is they like, well, how do you keep power low, and like, how do you do all this stuff? And they say, well, I'm on, in the cellular space, they're like, well, I'm on a cellular connection and it's not a public IP address, so I just don't use any encryption. And it's like, whoa, oh, that no. First off, you're not allowed to with Goliath, so you can't connect Goliath like that. But generally, I think that's not the best idea.
I think we're all aligned on that one. Yep.
Yeah. Okay. Good.
What I'm going to show here is using an ESP32C3 here, which is a little RISC-V module to connect to a Goliath instance that's running locally. So it's going to be talking over my local Wi-Fi network so that we can capture the packets in Wireshark. And we support a number of different platforms in the in the Goliath firmware SDK. I'm going to be showing working with the ESP IDF from Expressive, and we also support Zephyr, Modus Toolbox, variety of others, right? And they all, for the most part, depend on Embed TLS to get their DTLS support here. So Embed TLS added support for connection IDs a few months ago. And we use this kconfig option here, embed TLS SSL DTLS connection ID. So I'm going to set that to yes to enable using connection IDs when communicating with Goliath. So what I'm going to do here is pull up Wireshark, and you'll see that we're filtering for DTLS packets here. I'm going to hit reset on my ESP32C3 board here, and that is going to have it start up and connect to Goliath running locally. And then I'm also going to jump over here and use our IDF Pi monitor command to see all of the logs that are coming off of the ESP32 here. So I'll go ahead and hit reset and hit monitor, and we should see it come up here and see that's connecting to my local Wi-Fi network. So that looks good. Looks like it might have to retry here once. And I am going to pull up Wireshark, and let's actually restart it one more time. I might have missed the handshake, but we can see it come back. There we go, connecting to Wi-Fi, and over in Wireshark, we can see the handshake start to happen, and then all of the subsequent messages flowing through. If we looked back, you can see it's just running through this kind of basic Goliath set of services here and sending some stream data, getting OTA manifests, etc. What I want to focus in here is on the first few messages that are sent. These are the components of the DTLS handshake. So we have the client hello. DTLS, this is actually different from TLS, uses a hello verify request in which it sends a cookie that says, hey, in your next client hello, use this cookie. So we should see that show up here in the client hello. And in the client hello, we're going to see the connection ID extension. So connection IDs are added as an extension in DTLS 1.2. And what you're going to see from the client is that it has a connection ID of length 0, which basically says, hey, server, if you want me to send a connection ID, or if you support me sending a connection ID, I will do so, but I don't need you to send me one. Like we talked about, Goliath has a static IP address at the server, so we really don't need it to be sending us connection IDs. In the server hello, it is going to also support that connection ID extension, but it's going to return a connection ID and indicate to the client, please send this to me to identify yourself, which means that if your IP address and port changes, I'm still able to associate this connection that we're negotiating right now with the messages that you send. So I also mentioned that we're going to be using PSKs here. So in the client key exchange, we're going to see our PSK ID. If we open up the PSK client params, so this is just a test PSK ID here. And then the final message of a handshake from either side is called the finish message. And in this case, you're going to see that the server, which is not using connection IDs, is going to send an encrypted handshake message. So it's the first message that sends using the cipher suite that's been negotiated through the handshake. And the client is going to send one that's been indicated to be a connection ID record here. And that's because it is using the connection ID and wrapping the content that it would be sending in the encrypted record content of that connection ID record here. You'll then see that all subsequent messages from the client are going to be connection ID messages, and all from the server are going to be application data. So every message that the client is sending here is going to have that connection ID associated. Now, if we want to take a closer look here, we can get rid of that, and we can take our PSK, which is just test in this case, and I'm going to grab the hex encoding of that. And in Wireshark, we can go to our protocol preferences, DTLS, and specify what the pre-shared key we're using is, which allows Wireshark to then let us decrypt these messages and actually see the content. So I'm going to put in the PSK, and we'll see that these now get decrypted and see that both the client and server are sending finished messages. And if we go down and look at the messages that are being sent, we're able to determine that the payloads of these DTLS records, of these connection ID DTLS records, are actually CoAP payloads. So we still have our connection ID here, but we're also able to expand and see that there's some information in here that we're sending CBOR data to the logs endpoint. And then we actually have our CBOR data in here as well. And you can see some of the information that we're sending in our logs. And this is just going to keep sending. And yeah, so that's kind of showing how the handshake is different. You can imagine if we weren't using... Yeah, go ahead.
One thing that this one thing that this helps to reinforce for me is how much happening under the hood that I just don't have to think about, and I'm so grateful for it.
Yeah, absolutely.
Just like, yeah, thank you to the SDK. It's and and honestly, all the networking stuff that I wow, there's a lot going on down there.
Yeah, absolutely. And like you said at the beginning, users should never have to be diving into this level. But if you want to, and you want to see how we at Goliath are doing work to make sure that your connections are secure and efficient, it's nice to be able to have some guideposts to get down to that level.
Yeah, definitely. Wow. Okay. So so now if you were, we're not going to show it in this, but if you were to basically reconnect to a different Wi-Fi access point, or if you went to sleep for a long time and then you still presented that same connection ID token that you showed there, you're saying that then the Goliath Cloud says, hey, I know who this is. I'd come on through, right?
Absolutely. And if you didn't, it would just create a new connection and you do this handshake again. So communication would look the same. But over time, you start to pay the cost of doing those handshakes more regularly.
Right. Huh. Well, this is really cool. What enabled all this to happen in the first place? How did Goliath get this?
Yeah, absolutely. So we did all of the work here in the open, and it was really important to us. We benefit a lot from a bunch of open source projects that we rely on, and we also wanted to do this work in the open. So the primary effort that went in here was adding connection ID support to a library called Pion DTLS. Pion is actually a WebRTC suite of libraries, so it actually enables streaming video like we're doing right now, which is another place where you might have some lossy network, or you might not care as much about reliability. You might be willing to trade off reliability for getting packets there faster. And so we use that library on the Goliath server side. And so we added connection ID support there, which was a pretty big effort. And then, I mentioned already that we support a number of different platforms on the firmware SDK side. And for this to work correctly, right, both the client and server need to be aware of this extension and be able to negotiate it successfully. So we've also been either working on or supporting others in those communities and enabling connection ID support so that all of our users of our SDK basically just get connection IDs turned on by default. And that's going to keep rolling into each of those platforms that we support. And just by upgrading to new versions of the SDK, you'll get that benefit and start seeing that in your own products.
Yeah, this is one thing I think about a lot, actually, is, when people use something like Goliath, you basically, if you could always say, well, I could build this myself. I could build yes, you could. But when we move the things forward, you get both sides of the coin. You get the Goliath firmware stuff through the SDK, you get the cloud capabilities, and then they're tested working together as well. So like, I think about it like if I was going to my boss and talking about like, why I want to use Goliath. It's like I get all this stuff for free, and it just keeps rolling in, right? People like Dan over here are basically, you know, adding new things every day, and I get to benefit from it. So that's pretty cool.
Yeah, absolutely. And hopefully most of it, right? You never have to be any the wiser, right?
Yeah. Yes, I especially hope that. Well, Dan, thank you for telling us about this. I'm excited to see more, digging under the hood like this. I think it's super cool, and I think seeing the next thing the cloud team puts together for all of our users.
Absolutely. Thanks for having me, Chris.